There is one more analysis that I want to look at with the categorical data analysis. Remember, we're working with qualitative variables and we're comparing proportions ultimately with these analyses. But the one now specifically has two qualitative variables of interest. So there's two different factors, if you will, or qualitative variables. And the goal is to determine if the counts in one of these variables is dependent on the level of the second qualitative variable. Are they consistent across all the levels of the other variable? And so the data itself is actually going to be comprised of counts collected in the form of what's called a two-way contingency table. And these are referred to as two-way studies. And so let me show you the next slide and you can take a look at how the data is going to be represented. So think about a row being one of the factors or one of the variables, I guess a better word, and the column is another variable. There are I rows, there are J levels. So there's a total of I times J combinations of those. And the ends, the sample size, is going to be the first subscript is going to refer to what level in this first variable, and what the second one's going to be the level that you're talking about in the column variable. And so you talk about a row variable and a column variable. And so the sample size that you're looking at is made up of all these individual n's. So if you summed all the n's in the middle of this table, that's going to be n. There are row totals, there are column totals. And what we're going to be interested in, let me show you the test of interest here on the next slide. First, the observed counts, the expected counts, that's kind of one of the important things. The expected counts, you take a row total times a column total and then divide by a sample size. Now the n's refers to the actual observed counts. The e's are the expected counts. And these would be expected counts if things were what are called independent. So let me show you the tests that we're going to conduct. The test of interest, the null hypothesis says the two variables are independent. What does that mean? The counts for the rows don't really that's easy for me to say, don't really depend on, they're not determined by the columns, and the columns aren't determined by the rows. And so you have the null hypothesis saying that they're independent, the alternative says no, they're very dependent. Look at the test statistic here. Really what we're doing is we're looking, do the counts that we observe match what we'd expect? If we have independent outcomes, you should just be able to take rows and columns and kind of multiply them together. If they're not independent, if they're dependent, then that doesn't work. So we take a look at what we observe versus what we expect, square that and divide by what we expect. And as we've seen before, test statistics and p-values are things that are going to show up on printouts. And so it's the observed minus the expected squared divided by the expected, similar to what we saw in the one-way study. But as I mentioned, the test statistic and the p-value for the test will be found on the printout. The null says they're independent, the alternative says they're dependent, and we make conclusions by comparing alphas to the p-values. If p is low, we're going to be able to reject that they're independent. If we fail to reject, if p is high, we're going to be able to fail to there's insufficient evidence to indicate that the two variables are dependent. So same two conclusions, same method of making our conclusions, comparing alphas to the p-values, and taking a look to see what we get. Assumptions, we've seen these before. If you remember the one-way assumptions, you're going to probably remember these guys. We have n identical trials. We have k possible outcomes for each trial. The probabilities are p1 through pk. The trials are independent of one another. We need this for both the qualitative variables, and then our sample size criteria is similar to what we saw in the one-way study. The expected counts are all at least 5. The difference now is you have a two-way table. You have rows and columns, whereas before we just had a single dimensional table. We just had a row, so to speak, and all the expelled counts need to be at least 5. That's the sample size requirement there. The actual test is pretty straightforward. Are travel professionals equitably, it's easy for me to say, paid? A survey of 277 travels professionals, 103, 174 males, were asked, what do you think of your salary? And here are the responses. Salary too low, it's fair, I'm paid well. The males answered in one direction, the females, and really what we're asking is, do these percentages, the percentage of males who think low, does it kind of match up to the females? Do the fairs match up? Do the paid wells match up? Do we see consistent proportions across both males and females, Or do the responses to the question, how do you think you're paid, do they vary? Are they different for males and females? That's the independent question. Did I say it right? That's an independent-dependent question. And so we want to do a test to determine whether the responses differ by gender. And so the way we set that up, the test of interest is going to be, the null hypothesis is going to say that the response and gender are independent, meaning the responses don't depend upon which gender is answering. The alternative says the responses and the genders are dependent, meaning the responses you get depend. They're different for males than they are for females in this case. And so in order to do a test, we need a printout. And so I'm going to go to statistics. I'm going to enter the information. I'm just going to show you what these printouts look like. I'm not going to ask you to do a whole lot with this type of analysis, but I want to show you what the printouts look like. It gives me my table. So the different numbers you saw in that table, the 64, the 21, the 89, the 58, the 16, the 29. The order's a little bit different because statistics is going to look at the order and it's going to look at the way it's entered and it's going to do it alphabetically. And so too low was first in the table I showed you, equitable was second, and then paid well was third, and you can see the order's been changed, but the numbers are the same. And really what it's doing is saying we expect 76 of the females to say equitable. We only saw 64. We expect 45 of the males. We only saw 58. If we had independent outcomes, we should see 45 and 76 and 23 and 13 and 43 and 74. And you can see our numbers vary from that, but do they vary by enough? What do I mean by that? If the numbers, if they were, instead of 76 here, if it was 77, and this was, instead of 45, if it was 44, well, then the numbers would just vary a little bit. But we're seeing quite a big change there. We expect 23, we saw 21. That's pretty close. We expect 13, we saw 16. That's pretty close. 74, we saw 89. 43, we saw 20. And so really what we're asking is, do the differences we see from what's expected, are they due just to random variation, or would that make us doubt that we have independent outcomes? If things are independent, these expected values, the ones that are getting little red dots right now, that's what we should see. And so our test statistic, that's right here. Now it's a chi-squared test statistic, which doesn't mean a whole lot to you. It shouldn't, but this should. Your p-value is 0.0008. What do you do when p is low? Well, we make some conclusion like this. At alpha equal 0.01, we reject. There's sufficient evidence to indicate that the alternative hypothesis is true. There is sufficient evidence to indicate that the variables response and gender are dependent. We assume they were independent. We have evidence that suggests they're not. So you can't look at responses of one of these flight professionals. What are they called? Travel professionals. We can't look at the travel professionals overall. What this says is, if you want to look at the answer to that question, how do you feel about your how do you feel about the fairness of his or her salary? You can't look at males and females combined. You have to separate them because males and females look differently at that question. That's what this response, that's what this conclusion is saying. The two categories, the variables, response and gender, are dependent. And that's the test that we want to conduct here. It's a test to look for dependence. That's it. I don't want to do any more than that. There's some more stuff we could talk about, but that's really as far as I want to go with it. So when you are looking at a two-way study, it's a test for dependence, independence versus dependence. So hopefully that makes sense. Again, I'm not going to have you do a whole lot, but it is one more test of hypothesis that I could show you. No confidence intervals here to speak of, just a test hypothesis. So you should be able to state your null and alternative, be able to find test statistics and p-values, and then be able to interpret with p-values. So if you have questions with that, you know how to get hold of us. So long.